Welcome to 52nd session of AEE Western India chapter. And this is a session that is energy efficiency dialogues. So we have divided it into two parts, our webinar series. That is on the 2nd of Saturdays, we have a presentation, technical presentations. And on 4th of Fridays, we have this dialogue series. So this is second one in the series of energy efficiency dialogues. And today's topic is the role of IoT in energy management and sustainability. And our today's speaker is Mr. Manoj Telrandhe, who is basically an electrical engineer and having more than around 25 years of experience in energy efficiency. So he started his career with CTech Solutions, and at present he is in Dubai and CEO of TerraQ Technologies. He is certified energy auditor, then CMVP, lead green associate, junior solar PV expert, also ISO 50001 auditor. So welcome, Manoj, and has a vast experience in building sector and especially in monitoring of energy. And and today's topic is role of IoT in energy management and sustainability. So, so as you all know, so energy management and sustainability have become critical concerns for organizations and individuals. So with increasing pressure to reduce carbon footprints and optimize energy consumption, also to promote eco-friendly practices, it is essential to explore innovative solutions and strategies. So for this, we have pleasure hosting Manoj today, who's a renowned expert in the field of energy management and IoT monitoring, IoT devices-based monitoring. And and in this session, we will be exploring various aspects of energy management and sustainability and all the sectors of how IoT can be used for energy management. So let us begin with our conversation. So welcome, Manoj. Welcome to Energy Efficiency Dialogues by AEE Western India chapter.
Thank you.
So Manoj, my first question is, mainly when it comes to energy consumption, so buildings and industries are most affected. So we want to know what is the role of this IoT in achieving this net zero energy buildings and industries.
So see, achieving net zero, we are actually creating, kind of offset between what we are consuming and how we are reducing the emission in that. So IoT is not only about the monitoring, it also about the controls. So what happens now, we have seen that when we do the energy audits and all that, the first thing is we ask about the data. And then we analyze the data and we tell that, okay, these are the recommendations. And we have seen in most of the time when we have given the recommendation, the client either implement few of them and many of them are left out. Or let's say, even if suppose all are implemented, after 1 year or 2 years, you will find it out that the pace of that same conservation has gone down because now there are, lags in which the client is not managing the thing in the same way it was supposed to be.
Right.
So IoT helps in automating these things. So you can automate the things like earlier we were doing with BMS. Now we can do with the IoT devices. So you keep on continuously monitoring your performance, and it tells us that how exactly is happening. So the entire M&V process becomes, like digitized, and then you can understand whether it is going well or no. And it's a real-time analysis. It is nothing like that you have to wait for a complete month to come that bill to you, and then you understand that what exactly is the impact. It's a real-time monitoring. So when it happens, a real-time monitoring and control, you have a better control over the ECMs what you have implemented, and you can track the performance on a continuous basis. And that helps in the entire net zero and sustainability things, because then we are not leaving anything, go out of our hand because of the manual errors or anything. It gets monitored and controlled in the real time. That's the advantage of IoT solution.
Mhm. Great. I think also we should be able to monitor water management along with energy management using IoT. And how is that possible?
So what happens now? Earlier, when we talk about the energy management, most of the people only think about the kWh consumption. But in water consumption is also very much important. Though tariff of water is not that high, people are not that much worried about it. But the water meters can also be connected to the IoT system, and you can get a real-time data into that. So like what is your per hour consumption? Might be per hour getting the data will be too much difficult, because the meters what are there, those are actually battery powered meters when we talk about the IoT system. So the consumption of the battery becomes higher. So it can be set to send data in a frequency of, let's say, 8 hours. So every 8 hours you will come to know that what is your water consumption, and that data you can utilize to understand the consumption patterns. So the entire water management can be taken care of that. Another thing is leak detection. There are sensors now which can understand the leaks. So leaks can be understood in two ways: either an actual leak, or
Mhm.
second is a leak which is based on the water consumption basis. So for example, meter understands that this is your pattern of consumption, and suddenly the consumption has increased by, let's say, 30% or 40%. So it will send an alert saying that the consumption has increased. There is a possible chances of leakage. That is one thing. Second is identifying the actual leakage. So there are sensors which are either in the form of membrane. There are sensors which are just like, you keep on the surface, and when the water level is rising, it can understand that there is a leakage and it will send you an alert. So it helps in understanding the consumption as well as avoiding the leakages.
Okay,
And
great.
even in irrigation also. So for
Mhm.
example, let's say you have a industry in which a
Okay.
lot of part has been created as a green field, and you have an irrigation system into that. So now how the irrigation is working? Irrigation is working either on the time basis. Might be somebody is manually going over there and starting it, or might be somebody has done some automation and it is starting at a particular time. Now IoT can help more than that. It has the moisture sensors also. So
Mhm.
you put the moisture sensors in the soil, it understands whether the moisture level is up or down, and do you really need an irrigation? And if you need an irrigation, the command will be sent to the particular pumps and the sprinklers, and the irrigation will happen. So instead of making it time based, you can make it on demand base, whether it is required exactly or not. Might be in winter you will need less water consumption, in summer you will need more water consumption. That's how you can manage that.
Oh, got it. And like now, when it comes to energy, so one is the great energy, and solar energy is also now used a lot. And more of the infrastructures are based now on the solar energy. So, how do you use IoT to enhance the performance of these solar energy systems?
So there are multiple ways to do that. So when we talk about the performance of the solar energy, so we are actually talking about what is the yield, what is the expected yield, and what is the actual yield. Now the expected yield you carry out by the simulation, and the actual yield you are getting measured in terms of the kWh generation. But how do you know whether what you are generating is the best possible in that particular season or on that particular day or no? So there are multiple parameters which are affecting. First is shading, another is soiling impact. Okay, soiling creates a lot of problem if suppose the site is not accessible, you're not doing the regular cleaning. That is one of the thing. Second thing is that cleaning is also like time based. It might be scheduled on a particular field that okay, you go after 1 month, or let's say you go after 45 days and you do the perform the cleaning.
Mhm.
In case of IoT, you can put specific sensors which can understand that what is the soiling.
Okay.
Is there like a lot of dirt over there? So cleaning is required in 15 days, 20 days, 25th day, or 30th day. You can schedule that. You can understand that. That is one thing. Second, yeah, robotic cleaning we can do, but that is based on the scale of the solar project. If it is too big, that can be done. Second, a simple automation can be done in order to understand that what is your generation. Is it as per the performance or no? So if suppose there is a lot of dip in the generation as compared to the expected value, you can understand definitely there is some problem with the panels. Either cleaning is not done properly or something is happening over there. So these are multiple ways to understand that.
Mhm.
And now a lot of analytics comes from the, let's say, on the inverter itself. Inverter also gives a lot of data. So you can take out that data, you do some kind of analysis on that, and it will give a complete analytical model in order to understand that how exactly it is performing. Let's say one particular cell got damaged or one particular module got damaged. That can be understand whether it is impacting the entire string or whether it is impacting one particular area. That can be understood. So there are a lot of ways to improvise on the solar efficiency based on these IoT technologies.
Now, since we are talking about sustainability also, so waste management is again very important. And how to get benefited from this IoT devices for this waste management.
See, when we are talking about the waste management, so waste management is not only about the waste which is getting generated. The management of that is the entire cycle. Let's say your bins are full, then your skips are arranging. You are bringing that material to one particular location, right? And then you are composting or let's say recycling it. So IoT mostly help in understanding that whether the bins are full or no. There are multiple use cases of that. One of the use cases is like you have the waste bins, you put a sensor over there, and it tells you whether the bin has been filled or no. So once the bin is completely filled, you can arrange the skip. Otherwise, the person is going again and again over there, and you are like wasting a manpower. You can use that manpower somewhere else, which is exactly required, and the entire bin management can become, like an automated one. Another thing is now there are the sensors which can understand whether the it's like what kind of waste it is. It's an organic waste, it's a plastic waste, it's a paper. There are AI-based cameras and all this which can understand and segregate that. So we can also understand that what waste we are talking about, what kind of waste is getting more generated out of it. Then there are like so these are the use cases. Other than that, water management is some levels can be checked, so this all automation helps you to understand and manage it in a better way so that you can, utilize your resources in a way that it is managed properly.
Mhm. Okay. Now, when we talk about energy management, or like even if when we execute some energy saving projects, so most important factor is like benchmarking, energy benchmarking, and also the performance tracking after the implementation of the project. So at present, once normal in normal cases, what it is done is like whatever is the existing consumption noted by the plant people, right? Or I'll say after that, like submeters are installed, so monitoring of the readings, taking readings from that, and based on that, what we are doing is evaluating the result of the energy saving project that is executed. Now
Hmm.
with IoT, how we can improve this process?
So there are a lot of ways to do that. So first thing is that when you have IoT, you can correlate this data with multiple other data. So for example, earlier you were having only consumption.
Yeah.
Okay. So now you might be having some kind of production. You might be having the weather data. Okay, so whatever manual things are you are doing over there, you can develop a module and in which it will tell you that how it is getting correlated with the production, with the weather data, or with any other output what that particular machine or that particular electricity consumption has to give. And then on top of that, there are like machine learning modules, there are AI modules which can understand the patterns. Now, what exactly is happening with the patterns? Is the pattern correct? Is there, any kind of anomalies in the pattern? And then it starts to benchmark that. So, for example, let's say you have multiple buildings and you have square areas given into that, and you know that this is my kWh consumption per month per square meter. Okay, so the system will automatically start now benchmarking the data. What was the
Mhm.
earlier benchmark? What is the now current benchmark? And that benchmark they can compare with different kind of buildings, and in that you can do segregation that whether the building might be the area is same, but the building is one is a corporate building, another is a retail building, another might be a kind of restaurant, one might be anything else. So you can understand and group it, and then the grouping happens automatically, and the system tells you that which are falling out of the bucket or which are consuming more. Different modules can be created to it, so it helps in understanding the patterns and to understand the benchmarks. So IoT can do a lot of things which we are doing right now manually. And MNV also is very much important. So right now, let's say we are doing the linear regressions by taking the CDD data. So that entire thing can be done on an automatic basis in which CDD data is directly getting pulled from the weather stations. And then IoT tells you that what exactly is happening as compared to the CDD, whether the values are correct or not. This similar thing can be also used to forecast what will be the consumption next. So like that now this is my weather pattern,
Yeah.
what CDDs we are expecting, what kind of production we are expecting, or
Mhm.
let's say footfall in the building we are expecting. So it can give you that this is my trend
Okay.
for the future. Is it how it is going to consume? So you can understand like much earlier that what exactly is going to happen with the consumption. Shall we do something with that or no? That is also possible.
So, like when we are talking about production, so it means there must be some parameters on which production is dependent, right?
Yeah.
One of them even is a breakdown. So these, I mean, that exclusion, is it possible? I mean, because IoT, it cannot predict like when the breakdown is going to happen. Okay, so how that
So,
can be corrected?
so definitely, IoT cannot understand that when the breakdown is going to happen, but whether there is a breakdown or no, that it can understand. So for example, now when the breakdown happens, definitely there will be certain parameters which will change, right? So machine learning comes into play over here because it keeps on understanding that what are the patterns of the data.
Uh,
You see all the time patterns, the patterns, trend is like your friend in
right.
all the sustainability field. So these trends, the patterns they understand and they tells that, okay, there is some kind of change. So it means something is happening over there. So how machine learning is working? So we take the data from different machines or anything parameters, and then we train that model based on that. So once the model is trained, then you feed the actual data to it. Then the model can understand that these are the values which are not as per the pattern. So something is going wrong over there. You can actually train the model according to that, and it will give you output based on it. So there are two kind of model in machine learning. One is supervised, in which actually you are supervising the data whether it is happening properly or no. And there is one which is totally autonomous. So in autonomous model, what has happens that it is like more advanced than that one. It itself understand that no supervision is required. The models can itself understand that there is some kind of problem with the trends. And if suppose you find out that these are the trends which are related to breakdown, next time the model will not ask you that whether it was a breakdown or no. It will tell you that
Mhm.
okay, this data was up because of the breakdown, and it will omit those particular readings from the analysis. That can also be possible.
Mhm. Okay. So can you explain with an example of a healthcare sector of how IoT is supporting the energy management?
Not only energy management, it can help a lot of into the operation as well. Now let's talk about, because when we talk about sustainability, is not only about the energy management, it's also about the well-being of the people. When we talk about the 17 SDGs are there, you will see that there is like human right aspect also. So I was also wondering that how human right is related to sustainability. And when I did my one of course from CISL, so I understood that if the peoples are not treated properly, they will not think sustainably.
Okay.
So managing the manpower is also very much important. So sustainability helps in both the way. Now let's talk about the healthcare into energy management perspective. So you will find out that there are too many critical points like medical equipments, there are like blood banks, there are sample banks, temperature and cold room becomes very critical over there, right? And when people know that the things are critical, so as a human being, we have a tendency to overdo that. So might be a temperature is required of, let's say, minus 18 degrees Celsius. They might be keeping a set point of minus 20 degrees Celsius. only to avoid some kind of damages to the things,
Yeah.
or to just avoid that some kind of escalations which might be coming from maintenance or from the operators. Now here, when you have the IoT sensors and all that, you are reading the real-time data. Once you understand that real-time data, you also find out that what exactly the trends are happening, whether it is going up, whether it is going down. You can relate it with the door opening data. You can understand when the persons are opening the door, what is happening. When somebody is entering to take the sample or put the sample over there, how exactly it is behaving with the temperature. And then you can fix the thresholds that do I really need a temperature of -20? Do I need -18? Do I need -15? Because what is my variation? And according to that, then you can manage it. So a lot of energy consumption can be saved over there. You might have seen most of the time in clinics, when you go, wherever, when you are going to the clinic, you are feeling cold because they are unnecessarily keeping the temperature low. First is they need to maintain some kind of temperature to avoid bacteria and all that. But is that temperature also required? Because they might be keeping too low just to, the patients are, but you will feel that most of the time we are feeling cold over there. So they are avoiding any escalations, but we can maintain that temperature in a much better way in order to means by analyzing the complete data. That is one thing. And from operation perspective, there are different ways to do that. So like you can have tilt sensor now, you can have fault detection sensor, whether the person has fell down. There are like SOS buttons, which are, and these are totally wireless sensors I'm talking about. There is nothing like wire connection. So a person needs a SOS kind of a system, he can press the button and the entire, the concerned person will get alarm that yes, some patient got some kind of issues. Even like critical machines, like OT machines or X-ray machines, those can be connected. So at least to understand that, is there any kind of fault that we can understand. So a lot of things are there. Waste management becomes a very critical part in healthcare. So we can understand the bins are full or no, what kind of waste is going into over there, water management parts, and even odor. So for example,
Yeah.
now odor is a lot of problem in healthcare, right? So there are now odor sensors which can understand that, okay, there is a odor, a cleaning is required over there. That can be understood. Now,
Okay.
one of the things I was discussing with Microsoft, they are coming up with now AI-based cameras which can tell you whether the floor is clean or no, what time it has been cleaned. So it's
Okay.
like on based on the videos. So it
Uh-huh.
tells you the cleaning is required or no.
Okay. Right. So now AI is very much in talk, like everything we are talking about AI. So how we can integrate this IoT with advanced energy management solutions with AI?
So see, you don't need to go directly for the AI. There are like, we mostly use the machine learning part of it. We don't. So machine learning is one of the like type of AI which we use more over here. And another is based on the algorithm. So algorithms are mostly used when we are comparing two different trends, either with similar machines or with the historical data, or let's say in a predictive maintenance. And machine learning is mostly used in terms of understanding the behavior of the machines. So for example, let's say you have a big chiller and you have put a machine learning over there. It will understand that during what time, how my temperature is behaving. And then when the temperature data you get, the models will understand that are there any kind of predictive maintenance things which can be done. So it will tell you that whether the maintenance is to be done on this particular date or the next date. It can even predict the date that when exactly it is going to happen, when the filters are going to clogged, when will be my water temperature will be different, when what will be the condition of my pumps. So that's how AI can be integrated into it, and then it will give you all kind of analysis.
Okay. Now, since we are talking about AI and ML, so there is one question also. So what is the average energy savings that can be achieved by implementing AI or ML in HVAC, irrespective of the industry?
Irrespective of the industry, industry plays a lot of role over
Yeah.
here, because we need to understand that if it is a like a textile mill, there will be some different kind of, if it is a building, that is a different kind of thing. But HVAC, so it's not like that the percentage will depend only because of the IoT things and all this. but straight away you can consider like 10 to 15% savings are really possible. There is nothing lower than that. Another thing is a lot of misbehaviors can be avoided. Manual interventions can be avoided. Now, let's take an example of one particular commercial building in which a recommendation has been given that the set point has to be, logged properly. And so they find out that the people sitting over there, because office is having too many departments. So some people will be feeling hot, some people will be feeling cold. They are going and changing the set points. Okay. Whereas management has clearly told that no, you keep the 24 degrees Celsius only. Next, what did they did that? Okay, replace, put some kind of cover on top of that. They put some cover. Now the thing is like that. Okay, sometimes the cover can also be opened. Next thing they did, okay, remove the cover. We will put the thermostat, which will be having passwords. So they put the thermostat with the passwords. Now the interesting thing happened that technician coming over there. Now technician is, like in the HR hierarchy at the lower level. One officer is scolding him, he will do the set point reduction. So your password is also not working. Now what next will happen over there? So now these things are connected to an IoT-based cloud platform where now set point you can remotely send it over there. You can change the passwords remotely. And if suppose somebody is changing that set point, after 15 minutes, system will understand that it's a violation and it will again enforce the set point which is over there. So the entire manual intervention has been reduced. It has been removed. So now in all these scenarios which I have given to you, you can understand that how the percentage saving is getting varied. When the person is manipulating it, then you change the set point, and then now you are going to a final automation. Definitely the savings will be more over there because now the manual intervention has been totally removed.
Right. Yeah, it will depend on case-to-case basis, depending on the situations in the industry. Definitely. And now, how can we use this in transportation sector and in public places, and how energy management can be achieved in these sectors using IoT?
So transportation sectors, we can do the vehicle diagnosis. That is possible. So now most of the new type of vehicles, they come with some kind of OBD ports into this. So these OBD ports can be connected to an gateway and you get a complete data of the equipment online. So there are two things to do that. One is to understand the vehicle health. Another thing is to understand the behavior of the driver also. Are they accelerating more? Okay, how they are driving the vehicles. That can be understood. And these things can be then used for training them in order to reduce down the fuel consumption. Because if suppose the drivers are too aggressive, then it can be told to them that you don't do that because fuel consumption is increasing. You can also restrict it. There are ways to restrict that also, but all this data will help into that one. So that is related to transportation. One more thing you asked, I think transportation again you said.
One is in public places, like it is very difficult to maintain these devices in public places because people may.
No, so public places, these devices, maintaining the devices is not that difficult now because these devices are very small in terms of sizes. It can go totally hidden. Nobody will even understand the devices over there. And you use this data, these devices to find out any type of data in the public place. Might be you can count people counting. You can do based on the people counting. You can understand whether the temperature has to be raised or to be lowered. What kind of lighting requirements are there? Like how many people are there? Based on that, you can change the lighting requirement or even dimming requirement. And then so operation as well as energy consumption both can be monitored and controlled on that basis.
Okay. So when we are using this in public places, so definitely transition to smart cities becomes easier using IoT.
Yes. So now earlier, like most of the sensors were wired. So let's now consider that you are discussing about a smart city. So from smart city, we will say that let's consider first a smart community, which might be having, like 100 apartments, let's say standalone apartments. And then we can extrapolate the same learning on a smart city. So earlier, now there are street lights, then there are parking spaces, then there are like water management, all these things. So earlier, the every sensors were getting connected with a cable. Now cabling is very difficult. When you are doing at the start of the design and construction itself, then it is easy. But doing a retrofit in an existing thing, then it becomes difficult. That is one point. Second, what happens if suppose some kind of maintenance is required? So you need to again dig those cables and find it out that what exactly is going wrong over there. The sensors right now, what we are talking, those are all wireless sensors. So they can go into the community and you can get different types of data. You can do parking management, you can do Westbin management, you can do street light management, you can do management of the HVAC into the common area lighting management, so that all things can be managed through this. You can even understand that what kind of consumptions are there. Now, let's say in parking management, you are giving the, you have solar system, or might be you are having the electrical vehicles to be charged. So this system also can understand that how much is the consumption of those, whether it is working properly or no. All those things you can use.
Okay. Yeah. And like now, when we are talking about this IoT, so with every new thing that is coming in, so there are pros and cons of it. Okay. So are there any health impacts of IoT devices, like say radiation? I mean, it is of course very. I mean, it can be a question to someone, right?
And definitely, it's a very common question. So people keep on asking on that. So like now when we talk about the IoT technology, specifically on wireless, so wireless can be in two ways. One is like, let's say three ways actually. One is Wi-Fi, another is GSM technology, and third
Mhm.
is like LoRaWAN, in which we use the radio frequency.
Okay.
So Wi-Fi definitely we all are using. We know that now there are almost like all cities have Wi-Fi everywhere. So we don't see any kind of major health problem because of that. GSM also we are using. So we cannot say that mobiles are creating some kind of health issues. Okay, might be now 5G there was a row that okay it might create some issues, but right still we are using the mobiles. And radio frequencies which we are using for LoRaWAN, that is at the range of 850 megahertz. So those don't have any kind of intervention with the human health.
Mhm.
So when we check that, so it has been said in the studies that they don't have any kind of proven impact on the human health right now. So
Mhm.
whatever studies they have conducted on that basis, they are saying that there are no like any kind of proven impacts on the human health. So that's why these are very safe, no problem.
Okay. And what about using it in the extreme weather conditions? Like what can be the challenges?
Extreme weather conditions, when we talk about, there will be two kind of challenges. First is, like that sensor need to be, IP rating need to be increased a lot. It has to be like IP68, something like that. And when we go for the extreme IP ratings, then the signal strength also become one of the challenge because you are not giving any kind of opening. So that becomes an impact. But extreme conditions where we are using. So extreme conditions, we say that when extreme temperatures are there, or the locations are extreme. Like for example, those are totally buried somewhere, or let's say manhole kind of a thing, where the sensor will be totally, inside a manhole and there is no impact. Or let's say rainy conditions. So complete rain is there. So what's happening with that one? But now sensors and sensor like manufacturing is evolving a lot. In Dubai, we are using the sensors which are on the street light, and sometimes it is inside the street light. So in summer, the temperature goes like 50, and because the sensor is inside the light, the temperature can go like plus 70-degree also. So
Mm-hmm.
sensors are responding to that kind of conditions.
Okay.
Even in desert, we are using that.
Yeah.
And so this right now it is possible. So we don't see any impact of this. But yes, selection becomes a little challenging because you need to select the sensors in that way. And it might happen that all the sensors will not be available with those kind of IP ratings. So the more and more such cases will come out, the manufacturer will bring,
Keep
new technologies will
improving.
reach. Yes,
Yeah.
evolving.
Right. Great. Yeah. And like now when we whenever we introduce some new technology, so it is a general mindset that it will be for the bigger industries or a smaller businesses cannot afford it. So what do you think? I mean, is it affordable or not?
It is very much affordable. So affordability, when we say that, we also need to think about that we are talking about the payback, right? Like whether the payback for a small industry will be there or no, whether the payback for a big industry will be there or no. Now, when we talk about the small industry, definitely the number of data points are going to be less,
Yeah.
right? So when the number of data points are going to be less, your subscription cost for the software will be less.
Okay.
And second, the number of sensors required will be lower,
Mm-hmm.
right? And then the system can be, the solution has to be designed in that way that you will be getting most benefited out of it. So for example, now, let's take an example of a energy meter.
Yeah.
So connecting an energy meter, there are two ways to do that. Either you connect one energy meter, you put a gateway, the data from the energy meter is coming to the gateway, and then from gateway it is going to the cloud. Okay. Now energy meter might be costing X amount, gateway will be costlier than that. Now let's take this example to a small client who only need an energy meter because he don't have any other sensors, so there is no use of gateway. So putting both the things over there will increase the cost. There is another way of the energy meters who have inbuilt gateway in which you put the SIM card or you give a Wi-Fi connection or a LAN connection, and without using any other additional gateway, the data will directly come to the cloud.
Mm-hmm.
So that way the cost will go down. It will go down a lot. So it totally depends on what kind of things are required over there, how many data points we are talking about, and what solution we are designing. So it is nothing like that the industries, like the cost will be always higher. Another thing is big industries, there are gateways. One gateway can connect to 2000 points.
Mm-hmm.
There are miniature version of those, which will connect only the 50 points. So they can go like cost effective because now manufacturers are also understanding that our things will be brought only by the big industries. What will happen to the SMEs who might need only for the, like even for a smart home conditions
Yeah.
where only few things are required. So it will, so they are developing more and more things which are like with less number of points with lower cost. So it is possible. Cost effectiveness is not an issue.
Mm-hmm. Yeah, because we tried to do it for residential sector. I mean, that was monitoring of the solar power generation. But then we could not, I mean, at that particular point of time, we could not find a right fit for the business model for that. And like finally, we had to drop that idea. And then we concentrated more on industries where it was actually mattering a lot. Yeah. So if it is affordable, so definitely small industries can think of it, and rather they should go forward with this IoT based integration for energy management and sustainability. Now, so what are the key success factors for these IoT projects in energy management?
So key success factors, it depends on, like you don't go only for the monitoring unless and until you have control. There is no benefit of, putting an IoT over there because then it will become like as good as you are taking a manual reading and putting over it there.
Mm-hmm.
So success factors totally depends when you have a more and more control on the data and then more or more analytics on that. Because if you don't want to these two things, then there is no point in going for an IoT.
Mm-hmm.
So the more controls you have, the more analytics you have, this will decide how successful that case will become. These two are major important points. Having a control on the assets, and another is having a lot of analytics on that one. And analytics can be evolved over the time also. Might be you are understanding the data right now in one way. Might be tomorrow you will understand that the data is giving me some kind of other inputs also. So you can use that in developing another analytics, which will give you more benefiting to the savings.
Yeah, definitely. So at this point of time, I would also like to know, like, which kind of platforms you are using for this IoT projects. I mean, when or you, it's your own developed platform.
We have our own developed platform.
Okay.
So we use that one. So it's like a complete software has been developed for that. We can create different users into it, and then we give them the customized dashboard, what they want.
Uh-huh.
And in that, then there are monitoring, control, all those features are there. So like, let's say you have 5 HVAC systems, you can connect it, you can control it, you can understand even the electricity consumption, everything. And it becomes very user friendly. It is nothing like BMS in which one engineer need to understand that what data is there. If you can use an Android or Apple mobile, you can use this application also. It is that easy.
Mhm. Okay. Now, how IoT can be help in optimizing energy consumption during peak hours? Now, to my this question, there is also one question from the audience, which I would like to take it now. Like in case of time TOD tariff uh, in power sector, so could you suggest some ways in which home consumers can derive benefits from use of IoT? So again,
Home
Nitin.
consumer, yeah, home
I mean,
consumers
before
can derive. Yeah.
first you take the like for the energy consumption in the peak hours.
So peak hours, what happens is that now this is totally a TOD tariff when we are talking about, right? It might be at a consumer level, it might be at a demand side level also. So this now there are two ways to do that. One is only the monitoring the data. Another is like the controlling also over there, right? So now monitoring the data, what happens that when you are monitoring the data completely, it will tell you at what time, what kind of patterns are happening, when my consumption is happening. And then you develop that module and get some kind of alerts on it. It's like something is going high, the curve starts going up during the peak time. You can get alerts and you respond to those alerts manually and take some kind of action that, okay, these loads are not required right now. Let
Yeah.
it be over here. Otherwise, because the demand will increase and I will get penalized or might be having a higher tariff for that. So like monitoring is automatic, but the control is manual.
Yeah.
Another way is that you can do control also automatic, but in
Okay.
that way you will be needing more, hardware and sensors over there, which can understand that who is causing me that kind of impact, and then you label them whether these are critical, non-critical, and then the system itself you can tell it that okay, you switch off the non-critical one and keep the critical one. That is possible. So improving the behavior and controlling it through, let's say, automatic control, both way it can help you to avoid the, peak consumptions.
Okay. Um, Now, what are the challenges to ensure the data accuracy in this IoT-based energy management? Because data is very important, and like, I mean, plus minus 1 or 2% data accuracy is always accepted. But can we assume that it is uh, quite accurate data?
There is no need to assume that. So
Uh-huh.
let's see. Accuracy depends on, I will say, in case of IoT, accuracy will depend on three parts. One is the sensor or the meter, what you have installed over there. What is
Mhm.
the physical accuracy of that particular hardware? Okay. Second is how the data is coming to you, like at what frequency it is coming. And third is if suppose a network break happens, what is happening to that data? This will decide the accuracy of your final output. So when we are, installing the meters, like electricity meters or something, we go for the best possible accuracy which is required for that particular project. So let's say electricity meter, we will go for 0.5 plus. Okay. For thermostats or let's say temperature sensors, you can decide the resolutions what you need.
Mhm.
So the more accurate sensors you select, the more accurate data will come. So now the hardware part is clear, right? So we know that the hardware has to be selected in that way. At what frequency you want the data? Do you want the data at 1 minute interval? You want it at 15 minutes interval? That is
Mhm.
another way to understand that how accurately I'm collecting the data. Now, and what happens if the network is breaked? So let's say internet has been lost. So what happens at that point? So now the sensors itself have a provision to hold the data. They can store the data for like 1 week of period or 1 month of period in case of network failure. And when the network comes back again, it will again fetch the data from there. So your curves, your entire data will not be lost over there. So that's how you can check the accuracy of it. Now, another thing is somebody might say that, okay, my sensor is reading something, but I'm getting something else over here. That doesn't happen. The accuracy don't, get fade away in between the communication. Whatever value is there, the same value will be reflected over here. There is no accuracy depletion over the communication part. So it totally depends what kind of hardware, what frequency, and what kind of mitigations you have in case of loss of connection or any network like disruption is happening at that time only.
Yeah. Now, another question that comes to my mind is like when we are talking about the intervals of data recording. So, like when we say we do it in seconds, say 2 seconds or 4 seconds. So, amount of data that is generated is too high, and then managing those servers, managing those website, that becomes a database becomes a problem. So, how this is taken care of?
That's why you need to understand that you don't need a data on a 1 second basis. See, 1 second basis data, why we will need it? Like energy meter data, what we were talking
Say
about.
when we are talking about, say, in the iron industry, when there is a this furnace heating is going on. So
Yeah.
in those cases, I think it is sensitive. Time is every second is
Yes.
sensitive.
Yeah. So see, if suppose that is required, you can set the interval per sensor basis. It is not required that your entire system will be fetching the data on a per second basis. Let's say energy meter you need on a 15 minutes interval, one temperature sensor you need on a per second basis, right? So the more smartly you are thinking about the data, your data load will not be that much. So you can manage that. It is nothing like that the entire server is fetching the data at 1 minute interval. It also depends how the sensor is transmitting the data. So when we do the IoT configuration, we do at actually 3 levels. One is at the sensor level, another at the gateway level, and third at the cloud level.
Okay.
So sensor level, yeah. So sensor level itself, you can do a configuration that at what frequency it is sending the data. So that's how you can manage it. And then on cloud level, you can put analytics on that again to understand, should I keep that data or no? For example, you have but still the data will be coming. Whether you want to store it or no, that cloud can understand. So for example, you have a temperature which is 25, let's say, and for next 15 minutes, even at a second of 1 second interval, it is showing me 25 only because there is no change. So why you will store those 14 data in between? You store the last value because there is no change. When the change will happen, it will again store that data with a data and time stamp, saying that the value has been changed on this particular time and date. So that's how you can manage the data in that way.
Okay. So, I mean, this configuration is done by the system or the system integrators. Okay. Correct. And yeah, so definitely it will be this IoT when we are using IoT. So in addition to this energy management, and so we will be able to manage this carbon footprints also, right? Or
Definitely.
yeah,
Yes. So see, carbon footprint, what you are doing, actually carbon footprints are related, corollary, like output of the energy consumption.
yeah.
If you are managing energy consumption, you are managing the carbon footprint also.
Mhm.
The only thing is that people will be doing a lot of, conversion, that consumption is this and what is my carbon footprint into that. That entire part you can automate, saying that these are my different grade factors or conversion factors. So it will be showing you a data also in kWh, or let's say in water consumption basis or chilled water basis, and or fuel consumption. And at the same time, it will also show you the conversion based on the carbon footprint. So you can create your different dashboards. Which will tell you last month what was my carbon emission, this month what is my carbon emission. You can even integrate some kind of standards over there, like gold standards are there, or VRC is there. Those we can understand and find it out. Are we meeting those stipulated guidelines or no? That is also possible. So if you are managing energy consumption, carbon emissions will be also managed. Then
Mhm.
rest of the part will be like only the conversion. There are another ways to do that in which, yeah, but the benefit is, now you see the benefit. The benefit is that because your data is real time, you need not to wait for 2 months or period or 3 months or period, and then you are getting a report and understanding that my carbon emission has increased. Here it is giving you real time, so you can understand whether I'm doing good or no, and what going wrong. So you can
Mhm.
take timely action on that in order to meet all those targets what you have decided for yourself.
Okay, great. Now, one important question remains that, like many may be thinking of going for IoT-based platform. How to select that? I mean, what should we consider when we are selecting these IoT platforms? There are so many gateways available nowadays, and like so many platforms also, ready-made platforms also available, which say that for energy management. So, how do we select that?
So see, first thing you need to understand that, let's talk about the gateway first. So there are proprietary gateways, there are open source protocol gateways.
Mhm.
So I will suggest never go for a proprietary kind of a thing, because what happens in proprietary things, till the time you have contract with those people, you can manage that. The moment the contract is getting over because of any kind of reason, either because of the cost or because of any kind of reason, then you will not be able to manage anything into those kind of gateways. You will not be able to add more number of points. You will not be do some kind of programming into it. That becomes very critical. So you always take a system which is open source protocol where your engineers can understand. So instead, or let's say not your engineers, if suppose you are breaking a contract with one of the agency, if you are going for other agency, they will not ask you to replace the gateway again. And similar happens with the sensors also. Select the sensors in a way which can
Mhm.
be, on working on open source protocol, that you need not to change the hardware,
Mhm.
because hardware cost is like one time. So, and it might be significant in sometimes, because if suppose more number of sensors are there. So always go for a open source protocol thing. And don't misunderstand that open source protocol means those are not secure. It is nothing like that. Open source protocol means like this has been developed by certain agencies and it has been made available to the public where they can do more development on it.
Yeah.
Proprietary things are where manufacturers keep those things with themselves only.
Yeah,
They don't
there
give
may be
the
certain
source code.
limitations also
Yeah,
with.
yeah. Another part on, now let's say go to the platform. So always select a platform where customizations are possible. So now there will be two things. One is the cost and
Yeah.
another is the features. So think of the cost, that how much they are charging you on a per month basis. Is it based on the number of points? Is it based on the number of users?
Users.
Is it based on the number of sensors what you are putting? And then understand that how much is your cost. So you can understand what is my payback.
Mhm.
So that is now cost front. The major thing comes into the customization. Are you able to add your own site to that particular platform? Can you add by yourself one sensor? Can you add some additional customization or dashboard into it, either with their help or with your help? Can you integrate this particular platform with another system? Let's say you have SAP or Oracle or any other ERP system where you want to integrate that. If suppose the answers to all these questions is yes, then you can understand that, okay, this platform is good.
Mhm.
And how it is scaling up. Means, can you scale it to multiple locations? Are there any limitations of that? So once you find out the answers to these questions, then you can understand that yes, platform is okay. Because sometimes people will say, no, you cannot do customization. You cannot add one more site. Or
Mhm.
some of the platform will say, no, you cannot change the temperature. You have to call back to our team and then they will change the temperature.
Yeah. Okay.
So that becomes too much, that doesn't make any sense, because let's say you are in a healthcare where you want to change the temperature immediately and you need to give a call and then they will be giving you a call back, which will be having an SLA of, let's say, 4 hours or 24 hours. You will be losing that particular either operations, even the savings. So you need to find out the things which are easy to use for yourself. Right. So it is just like using a mobile phone. Once you have bought the mobile phone, the hardware and software is yours. You should be able to manage it.
Manage it.
Might be you will need some kind of support from the manufacturers or the service provider, but should not be on each and every step. That should be your selection criteria.
Okay. So I think we have covered all the questions. And now, thank you, Manoj. That was great. I mean, I think we have discussed in detail and covered a lot many sectors and lot many queries that we could. But in addition to that, now we have some questions also. So let's go to those questions. Although some questions we have already clubbed with during this presentation itself. Now, that one says, yeah, Praveen Avtade says, could you present some dashboards or case studies? Since Praveen, since we have decided this as a one-to-one conversation, we are not presenting anything. So Manoj, if you have just a screenshot or something, and if you would like to share, that is fine.
Right now I cannot share, but
oh, no
this
problem,
might
no
be in
problem.
future.
Yeah. So Praveen, we will be sharing with you the details later on this. And now there's a question like, is there any certifications for energy auditors on AI and ML? Right.
There are no particular
There are no
certifications, only
yeah,
energy auditors. But
uh,
yeah, on AI and ML, there are a lot of
got
courses.
many.
Yeah, there are too many courses. So you can go through the syllabus and understand whether these courses are relevant to you or no. Because sometimes, most of the things are related to the programmers. There might be some courses which are related to the use cases and the users, that how exactly they are going to have. So the moment you understand the syllabus of that, the content of that, you can select which course is suitable for you.
Okay. Yeah. I hope that answers your question. Now there's one question from Cristoni. Mr. Cristoni, he says that, like, if I am doing, although it's not related to IoT, but still let's take it. I am doing an energy audit in 2025. Is it okay to take this as baseline 23 September 23 to September 24, or take this as a baseline 20 January 24 to December 24, as per the M and V aspect?
Okay. But if suppose you have more data, you should take more baseline into that. There is no need that only going for a 12 months data only. If suppose you have 2 years of data, 24 months data is there, 48 months of data is there, that is actually better to take more data, because there you can understand that how are the patterns. It might happen that last month, let's say in 21 there was corona, right? There might be some cases such kind of things are happening where the consumption is not that much. So what you will do with that one? So more data you get, you will always be having a better analysis over it. Though CMVP says that, okay, 12 months of data is sufficient, but I think having more data will always give you, advantage only to understand that whether things are going correct or not.
Okay. Yeah. Now, next question is from Mr. Sanjeev Sinha. What are the important cybersecurity issues that need to be addressed when IoT is used?
It's the most important question. The moment you talk about internet, people talk about the cybersecurity.
Cybersecurity, yes.
So now let's understand when the cybersecurity comes into the picture. So the cybersecurity comes into the picture when you are giving internet to the gateway, right? Because now that data is going to be on the like internet. From sensor to gateway, it is not on internet. From gateway to like cloud, it will be on the internet. So how you are giving the internet, that will decide whether your data is safe or no. Are you using a SIM card? Are you using a Wi-Fi? Or are you using a LAN cable? So most of the time, what happens when we are doing the project, we are actually asking clients to provide their WLAN network. So when they provide the WLAN network, there are securities, they are doing the configuration on the port level, on the even, what you say, URL where the data will go. So, and they have the firewalls on their servers. So once that cable is connected to the gateway, one particular address has been given, only that gateway will work on that. If you change anything in between, if you remove that and you connect your laptop, the data will not flow. It will not be able to access the data. So the cybersecurity will depend on their IT team, how they are providing you all these details. If they have proper firewalls already in place, so this can be done. So data can be channelized. So when we send the data, we give our particular port, we give our particular IDs where only the data will go. And this data is totally encrypted from one end to another end. If so somebody is intercepting in between, they cannot understand that what temperature I am sending, what data is going over there. It will not be like encrypted. Means it cannot be decrypted over there. So cybersecurity is totally depending on the IT team over there. The more their IT is secured, yes, this data is secure.
Okay. I hope that answers your question. Now there's a question from Mr. Kamlesh Kumar. Why energy auditors often focus on more significant energy saving opportunities and energy losses due to friction and lubrication might be overlooked or not considered. And by considering energy losses due to friction and lubrication, energy auditors can provide more comprehensive and accurate assessments, leading to increased energy efficiency and reduced energy consumption. How IoT can address it? I think it is the 80-20 rule. Like if you target on the 20% high consuming equipment, you may be 80%. I mean, I'm just taking the example. 80% of the areas are covered, and from energy conservation point of view, that is one of the major issue. But you can answer it better.
IoT, I don't know really how it will help over there. So as long as you have some points which we can read, yes, data can be taken. Like, so it totally depends on what kind of data we are looking about. See, IoT is not, like a magic stick. It is just like giving you an insight in a real-time basis.
Yeah.
So it gives you an insight, and then you put more and more analytics into that and understand it. So if suppose there are some points which we can take, if we can understand what is meant by lubrication, what data we are actually talking about, what point we are talking about, when we are thinking that friction, so what exact data we are talking about. And if we can capture those data points with the help of sensors, the data is coming to us, yes, then it can be done. And we can also understand whether it is impacting that particular consumption or no, because we will be studying two different trends to understand that what is the correlation of one trend with the another trend. That's how IoT works. It is nothing like that in one particular thing it will be helpful. It can be anything.
Yeah. There's one question that I'm taking from Mr. Sarabindu Mohanta. Is BMS an IoT-based system? Building management systems.
Mm-hmm.
So is it an IoT-based system? That is what is his question.
No, BMS
Not necessarily.
and BMS we cannot say as IoT. BMS looks like IoT a little bit, but that is not IoT. Because what happens in BMS first we are doing into the new buildings only. We are getting constructed. You don't see major projects into BMS which are doing as a retrofit. Whereas IoT can be done in the new buildings, in the existing buildings, or any type of a thing. Or let's say even industries also. It can go any level. The second difference is that BMS is always centralized. Centralized means you need one machine in that particular facility itself. Whereas IoT, because data is coming to the cloud, you can manage the facility from anywhere. Right? You might be having a client in Delhi and you are based in Nagpur. You can control that facility from Nagpur, any part of the world. That doesn't, impact the usability of the IoT system. Another thing is that data analytics. So BMS don't provide a real-time data analytics, whereas IoT, the moment data is coming over there, you can analyze the data there and there itself. You can automate the analytics. The value has come, the analytics will start from that particular time. You don't need to hold the data to find out that what analytics I'm going to do on that one. And then BMS is very, you can say, hardware intensive. A lot of hardware is required. Sensor, then cabling, then DDC panel. After DDC panel, again cabling, then gateway, and then machines. Whereas in IoT, what happens that you can reduce all these things in a much better way. You have a sensor, you have a gateway, and done. Data from sensor to coming to the gateway, and then from gateway to the cloud. So IoT, I will say that much more advanced than computing power. In BMS, you will depend on the computing power of that particular machine itself. Whereas IoT, the data is coming to the cloud. You can use the entire cloud virtual machines to provide a lot of analytics, which can happen over there. It will be fast. AI you can implement into it, machine learning you can implement into it. AI and machine learning you will not be able to implement into the BMS system because those are like in existing machine. So I will say that IoT is like a much advanced version of a BMS, much better than that.
Manoj, we will take another 2 minutes.
Yes.
Professor Gandhe wants to talk to you, and like he is. Gandhe sir, you will have to unmute your mic and ask your question. He wanted to talk. Hello.
He is still on mute.
Yeah. Gandhe sir, you will have to unmute yourself. Otherwise, he has put up the questions also in the chat box. So I think I will read the questions because many are waiting in the session. So it's not right. So his question is like, since the subject is new in India, how can you help to generate interest among energy managers or engineers, and how to educate people?
Okay, how to educate the people? The more and more you learn and understand about it, the interest will be developed. Now I think India is more educated on AI and machine learning kind of a thing. There are a lot
Yeah.
of software companies who are working on that. The only thing is that you need to find out the use cases, how it will be related to energy management and sustainability.
Mhm.
So awareness is already there, but I think presenting the use cases, presenting the actual data, that will make people more understand about it. Because when we talk about AI and IoT or even machine learning, most of the time the software people are talking about this one. We need to find out more engineers who are like auditors and all that who can talk about this and present the use cases. The more the use cases are presented, I think people will understand it in a better way.
Uh, I think he is now logged in from another terminal. And so there is a problem with your microphone basically. That's what is the system is showing here. Yeah. And then again, his question is, at what level of energy will AI with AI system be cost effective? So it's
So
basically
see, you,
IoT is quite cost effective.
but see, when IoT provider, a cloud-based platform provider is developing an AI, he is not developing a AI only for a client A or client B or client C, right? He is going to provide this service to the multiple clients. So he is not charging for those AI development to you only. That cost is actually dispersed over the number of clients. So we can, so it is not going to increase the cost of the energy efficiency drastically only because you are using AI. For
Yeah.
example, now Google is giving AI free of cost in their mobile, right? You are already using that. Google Bard
Yeah.
you are using or Chat GPT you are using. Those
Gemini
are
is
like,
also there now.
yeah, language models. More
Mm.
in machine learning, you will be having more different models where you can use the data. So I don't think that it will be too much costly. Cloud-based platforms, how they are integrating it and how they are charging on that. But if suppose the subscription cost is going too high, for example, now Microsoft have Copilot. They started using providing Copilot to the professional users for Microsoft 365. So they will be adding some dollars into the subscription cost, but it doesn't mean that the cost will go too high because now they need to be in competition. Now, let's say you are trying to take one cloud-based platform from one of the IoT provider, and there is another IoT provider who is saying that I am providing you AI. This is my cost. So unless and until people will become cost effective, how you are going to buy that product? So that's why Microsoft and Zoho are understanding they will reduce the cost further to give these benefits to more and more people.
Thank you, Manoj. Thank you for patiently answering all the queries and questions that we put up. And thank you, audience, for attending this session. Hope you like this new format, and we would like to hear feedback from you. And those who are looking for memberships, you can directly go to the website aeecenter.org for membership, and just let us know once you become the member. Also, now for Manoj, all those who want to ask further questions to Manoj, I have already shared his email ID in the chat box. He can be reached at hellomanoj here at gmail.com. So for further questions, you may contact me, or you can directly contact Manoj so that he can answer your further queries. So thank you everyone for attending this session, and many of you are regular. We are continuing this series for more than 2 years now, but and it's very heartening to see that some people are joining us right since beginning. So thank you so much for the support. Thank you, Manoj, once again for
Thank you very
being
much.
here
Thank you.
and answering us and enlightening us on IoT for energy management and sustainability. Thank you. Bye,
Thank you.
everyone.
Thank you very much. Thanks. Bye.